Hi, welcome to CSC 114, Introduction to Object-Oriented Programming. The topic of this lecture is Recursion Part 1. So in order to understand recursion, let's start with an example of recursion. So here we have to compute n factorial given an integer and we want to compute n factorial. So this is the symbol, the exclamation mark is the symbol for n factorial. We'll say n exclamation mark when we have to compute n factorial. So how do we compute n factorial? Well, for that we'll have to multiply all these integers. We'll start with 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 5 all the way till multiplied by n minus 1 and then finally by n. So this is how n factorial is defined. Now let's think about n minus 1 factorial. So how is n minus 1 factorial defined? So n minus 1 factorial would be 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 5 so on and so forth till n minus 1. Right, so we can see an interesting relationship between 1 and 2. So the relationship between a 1 and 2 equation is that n factorial, if you look at, is equal to n minus 1 factorial multiplied by n. Right, so if in n factorial you pay attention to these multiplications, 1 multiplied by 2 multiplied by 3 4 so on till n minus 1, then these initial terms are computing n minus 1 factorial only, right? So we can express n factorial in terms of n minus 1 factorial. So this is a kind of recursion here, where the factorial of n has been defined in terms of factorial of n minus 1. All right, so what we have here, the same thing, n factorial equals n multiplied by n minus 1 factorial. So now let's think about programming. If somebody is saying that we have to write a method that computes n factorial, then we'll have to, we can use the same expression that we have over here in programming as well. So for this thing, when you're defining n factorial as n minus 1 factorial multiplied by n, then we need to think about a stopping criteria. As an example, when you say 5 factorial, then you'll say 5 factorial is equal to 4 factorial multiplied by 5. All right, then we need to think about 4 factorial, and 4 factorial would be 3 factorial multiplied by 4 then multiplied by 5. So we need to stop somewhere, right? N factorial has been defined in terms of n minus 1 factorial. So there is something called as the stopping criteria. So for factorial, the stopping criteria is the value of 0 factorial, and 0 factorial is equal to 1. We know that. Therefore, if we have to implement this factorial using recursion in programming, then we do need a condition like this, which is in fact correct. We know that 0 factorial is 1. Therefore, if we define a method called factorial, then the factorial on the integer or 0 is 1. All right, so when we know the stopping criteria or the base criteria of a recursion, which is factorial of 0 as 1, then we can define the factorial recursively, and we'll say that the factorial of n is in fact n multiplied by factorial of n minus 1, and this is applicable for the value of n greater than 0, and for n is equal to 0 we know that from the line number 4, right? So we now have 1 2 3 and 4 equations, and that's how we can handle this recursive formulation of factorial. All right, so now is the time to write the code for factorial. So let me do that in the demo, and then I'll come back on the lecture slide and we would recap my demo. Okay, so I'll quickly hop over to the IDE. That is right here. I'm using Eclipse. So right here in this Eclipse, I do have some skeleton code where we have this scanner class, for the reason that I want to get the integer value from the user, and for that integer value I will invoke the factorial method. So here for that purpose we have an input object that is of type scanner class, and then this input object has been closed on line number 5 to avoid any warning. So now let me write a method for computing the factorial. So I will write public static int, and the name of the method would be compute factorial. You can call that factorial as well, but I'm calling it compute factorial because in my lecture slide I have used this method name. So let's define a compute factorial method on an integer parameter n. So how can we compute a factorial? Well, based on what we have just seen in the formulation, if n is equal to 0, right? If n is equal to 0, we would return 1. We know that factorial of 0 is 1. Else, what we return? Else we will return n multiplied by compute factorial. This f should be uppercase, compute factorial of n minus 1. Right? So what we have done in this simple code involving recursion that runs from line number 7 to line number 12, we have simply implemented the expression over here. So here goes the expression, right? We know that factorial of 0 is 1, and any factorial of n greater than 0 is n times factorial of n minus 1. Right? So factorial n is equal to n times factorial of n minus 1. Right? That's what I implemented over here. Okay, so now what we should do, let me get some value from the user. X is equal to input dot next int. Right, so in the variable x, I'm getting the value for an integer from the user. Let's prompt the user for an input integer. We'll say please enter a non-negative integer. All right, and that's what we are getting in x. Now what I should do, I will invoke let me also declare another variable fact, which is for factorial. So here I will invoke compute factorial on the variable x. Right, so x is what we are getting from user. So let's print it out. We'll say factorial, wait a second, factorial f, I want to write in capital, factorial of, and let's use this x. All right, and we'll say is, right, and now we'll use this variable fact. All right, so what we have done here, one more time, in the main method, input is the scanner object, which we will use in order to accept the input from the user using next int, and that integer input from the user is stored in the variable x, and on x we are invoking the compute factorial method that we have written, and this factorial that is computed has been stored in the variable fact. That is what we are printing out using the system.out.println. So factorial of x is fact. Now one more time, let's have a look at this compute factorial method that we have written. Well, it is public static int. Int is the return type, and the factorial value is going to be an integer. So the parameter that compute factorial accepts is n, which is an integer type. Now inside the compute factorial method, we are using the formulation of factorial. If n is equal to 0, then we are returning 1. Otherwise, we are returning n multiplied by compute factorial n minus 1. So on the line number 15, we are making the recursive call. Why is it recursive? Because we are calling this method itself, right? We are saying compute factorial, and in this recursive call, we are calling it for one less, right? So if compute factorial has been defined for the parameter n, but on the line number 15, we are saying n multiplied by compute factorial n minus 1. Right, so this is interesting. So let's run this program. Okay, so first I will put the value of n as 5, right? So 120. I know the factorial of 5 is 120. Let's run that for few more values. Like factorial for 4 is 24. I know that, which is correct. And then let's try it for 3 also, which is 6. That is correct too. And finally we will try this on 0, right? And 0 factorial is 1. Okay, so now I'll take you back to my lecture slides. So we have done all these things, right? Now let's look at the code which I've written in a more systematic way using my lecture slides over here. So what you would need to do is to define a class. So if you are writing a fresh class where you have the only method you have to write is for compute factorial, then better declare your class. You should say public class compute factorial, because this class is probably dedicated to factorial computation only, right? And since you want to make your program more interactive, you might like to get the input from the user. For that, you'll have to import java.util.scanner class. Then inside this method you would write a main method, just the way we do, public static void, and inside the parenthesis of the main method goes string array called args. Okay, and this main method starts here and ends here, and the whole class is starting from this point and is ending here in between these two curly braces. Main method is defined between these two curly braces. Now what next do we have? Well, we'll create an input an object named input, which is of type scanner class, using the constructor scanner here, system.in, which is for the keyboard, and we would need the new keyword. Then we are prompting the user for a non-negative integer, and in the variable n, which is of type integer, I'm getting that value from the user by saying input.nextInt. All right, next what I'll do now, I will invoke the factorial method, which I still need to write. Okay, and I'll say system.out.println factorial of n, this integer right here, is the result of this method factorial, which we still have to write. So here goes the skeleton of the factorial method. You'll say public static int factorial, and it is defined on n, which is an integer variable, and this factorial is defined in between these two curly braces, right? So now we'll take care of the base case. If n is equal to 0, we return 1, else we return n multiplied by factorial of n minus 1, right? So this is the recursive connection. Factorial of n is the main method, and inside that method we are recursively invoking factorial of n minus 1, right? And this keeps on recursing till we hit the base condition when n is equal to 0. All right, so let's try to learn about the mechanism behind computation of factorial, and we'll do that with the help of this formulation, right? This is the general formulation of factorial. We know that factorial of n is equal to n multiplied by factorial of n minus 1. This is the case when n is greater than 0. Otherwise, if n is equal to 0, then factorial of 0 is 1. Okay, so now let's compute factorial of 3. So we have to apply this formulation here. 3 is greater than 0, so this, this formulation will work. Factorial of 3 equals 3 times factorial of 2, right? So this is where we are doing the recursive call. For 3, we are saying 3 multiplied by factorial 2. How do we compute factorial 2? Well, for factorial 2, we'll use the same expression, right? So inside the parenthesis here, we are computing factorial 2, which is 2 times factorial 1. How about factorial 1? Well, for factorial 1, we will say 1 multiplied by factorial of 0, right? So this is the recursive call that we are making to the factorial computation. And we know that factorial of 0 is 1, right? So this thing is 1. Therefore, finally, when we hit factorial 0, now we would start substituting the value. Factorial of 0 is 1. That's what we have here. Now we can do the whole computation. 1 multiplied by 1 is 1. Right? So this all gets reduced to 1. And 2 multiplied by 1 is 2. Right? And then finally, 2 multiplied by 3 is 6. Right? That's how we compute factorial 3. Alright, so now what we will do, we will try to understand how this recursion is working. When we have written the factorial method, now we want to understand how is this factorial method is working. Right, so if you were to compute factorial 4, then we know that, mathematically, we know that 4 factorial is equal to 4 times 3 factorial. Right, so when you execute factorial 4 from the main method, and we are looking at the stack as well. So for method invocation, we do have a stack involved. So main method is working here, and the main method invokes the factorial 4. Right, so main method will need some space on the stack for its own variables and all. Now you know that 4 factorial is defined as 4 multiplied by 3 factorial. Right, so what will happen, invocation of factorial 4 will result in the invocation of factorial 3. This is recursive thing, right? So when you say factorial 4, then in the factorial 4 you will invoke factorial 3. So in the step 0, which is inside the main method, you will invoke factorial 4, step 0. In the step 1, now factorial 4 will invoke factorial 3, because factorial 4 is equal to 4 times factorial 3. And for that, what will happen now, we will need the space for the method call, which was with the value 4 for factorial method, right? So now we are using stack. At the bottom of the stack, we have the activation record for main method. And then since the main method invoked factorial 4, so we had to give some activation record for a method for factorial method invocation with the value 4 as the parameter. Now method factorial 4 is invoking factorial 3. So we will need another activation record for the factorial method invocation with the parameter value being 3. Right? And then we know that factorial 3 would invoke factorial 2. Factorial 2 will invoke factorial 1. So that's how you can see that now the stack is growing up. Right? And now factorial 1 will invoke factorial 0. So we would need to put the activation record for factorial 1 as well. Factorial with parameter being 1. Right? And finally factorial 1 would invoke factorial 0. Therefore, we would need some activation record for the factorial method with the parameter value being 0. But when you invoke factorial 0 with the n being 0, you know that its value is 1. Right? So when you hit n is equal to 0, then you know that the factorial of 0 is 1. You don't need to make any recursive call further. Right? So what will happen now, when you know that factorial 0 is equal to 1 on step number 4, then it will return the value 1, right? And now we will start coming back from the recursion. Now it will unwind, right? So there's winding and unwinding. When you keep calling recursion, then that can be considered as winding the recursion. And when you start returning after hitting the base condition, that is called unwinding the recursion, right? So from step number 5 here, we are returning the value. You know that factorial 0 is 1 now, right? So now you will return back from the recursion, right? So what will happen next? Well, now you see that the activation record which was used for factorial 0 has been removed from the stack, because we know the value of factorial 0, which is 1. You return 1, right? Then in the step number 6, sorry about that, in step number 6, we know that now the factorial 1 has been computed, which is 1 multiplied by 1, right? So you return the value 1. All right, and you should see here also that now the activation record that we had reserved for factorial 1 has been removed from stack. You keep moving up. So now the value that will be returned at step number 7 for the value of factorial 2 is in fact 2. 2 multiplied by 1. 1 is the value of factorial 1. So we keep moving up, right? In step number 8, the returned value is 6 for the reason that factorial 2 is 2. That's what we computed here. So 3 multiplied by 2 is 6, right? And then in the step number 9, you will return 4 multiplied by the value of factorial 3, which is 6. So 6 multiplied by 4 is 24. And look at the stack. Now we have returned to the activation record of the main method, right? And that's how we have everything in at one place. Here you are looking at the stack trace. Stack trace means the situation of the stack, the call stack, right? So this is the call stack, which we use when we invoke methods. So in the first scenario, the first stage, you had the activation record for factorial 4. The space required or the activation record, that means the same thing. In the second step, when you invoke factorial 3, we need another activation record for the factorial 3 on top of factorial 1. In the third step or stage, we invoke factorial 2 from the method factorial 3. So another activation record needed for factorial 2. In the fourth stage, we need another activation record on top of a stack for factorial 1. Right? In the fifth stage, we needed another activation record for factorial 0 on top of the stack. Right? And when you computed factorial 0 is equal to 1, then from stage number 6, we started unwinding the recursion by returning the values. Right? So here you can see that the activation record for factorial 0 has been removed. In stage 7 or step 7, even the activation record for factorial 1 has been removed, right? So it is not here. Then in the from step 7 to 8, you would see that activation record for 7 for factorial 2 is also removed, so on and so forth. And the final stage, which is the stage or step 9, we are left with the main method only, where now we have the computation, the value for factorial 4. All right, so I will stop right here. Thank you.